What exists 6,371 kilometers below Earth? Most of us spend our entire lives standing on the same planet. We build cities on it. We cross oceans on it. We dig into it for water, oil, and minerals. It feels familiar, almost completely understood. But there is one detail that quietly changes everything. Humans have walked on the moon. We have sent spacecraft beyond the edge of the solar system. We have photographed distant galaxies billions of light years away. Yet we have never reached the center of the planet beneath our own feet. Not even close. The deepest hole humanity has ever created reaches only about 12 kilometers beneath the surface. Compared to Earth's full radius of roughly 6,371 kilometers, that depth is almost insignificant. And that raises an uncomfortable question. If nobody has ever been there, how do we know what exists inside Earth? At first, the answer seems obvious. Surely we drilled deeper, sent special machines underground, or perhaps discovered enormous underground caverns leading toward the center. None of that happened. In fact, the deeper scientists tried to go, the less Earth behaved the way they expected. What looked like a straightforward engineering challenge slowly became something much stranger. The greatest obstacle wasn't simply digging farther. It was trying to understand a world that refuses to reveal itself. Long before anyone imagined drilling thousands of meters underground, people could only guess what existed beneath them. Ancient civilizations imagined vast underground worlds. Some believed enormous caves stretched beneath continents. Others pictured rivers of fire flowing below the surface. Without evidence, imagination filled the empty space. Today, we often smile at those ideas because modern science appears to have replaced them with certainty. School textbooks confidently show Earth's crust, then the mantle, then a liquid outer core, then a solid inner core. The diagram looks complete, almost finished, as though someone had sliced the planet open and simply looked inside. But that picture conceals an extraordinary truth. No human being has ever seen those layers directly. Not one. Everything below a tiny fraction of Earth's surface remains physically unreachable. And yet scientists can estimate temperatures, densities, compositions, and even how different regions behave deep inside the planet. How is that possible? That mystery begins with humanity's greatest attempt to reach downward. In the far north of what is now Russia, scientists chose a remote location on the Kola Peninsula. Their goal sounded simple: drill deeper than anyone ever had before. Not to find oil, not to discover gold, not for military purposes. They wanted knowledge. The project eventually became known as the Kola Super Deep Borehole. For years, engineers pushed farther underground than anyone in history. New records fell again and again. Every additional meter promised another glimpse into a part of Earth no one had ever seen. From the surface, the achievement sounded extraordinary. Surely this would finally reveal Earth's unseen interior. Then the planet began pushing back. The farther the drill descended, the stranger the conditions became. Temperatures rose far beyond what many researchers had predicted. Rock that was expected to remain rigid began behaving differently under immense heat and pressure. Equipment designed for one environment suddenly faced another. Progress slowed. Every new section demanded solutions that had never been tested before. The challenge wasn't simply building a stronger drill. Earth itself was changing the rules. Eventually, after reaching more than 12,000 meters below the surface, the project stopped. Not because scientists had reached the mantle, not because they had reached Earth's center. They hadn't even come close. Despite decades of effort, humanity had penetrated less than 1% of the crust in many places on Earth. The deepest hole ever drilled turned out to be little more than a tiny scratch on the planet's surface. That realization changes your perspective. If our greatest engineering achievement barely touched the outer skin of Earth, then almost everything we confidently describe below that point must come from somewhere else. But from where? The answer begins with an idea that seems almost impossible. Imagine standing outside a house you've never entered. The doors are locked. The windows are covered. You cannot step inside. Yet somehow, you are asked to describe every room, every hallway, and even what materials were used to build it. It sounds impossible. Unless the house is constantly leaving clues. Earth does exactly that. Almost every day, somewhere on the planet, the ground shakes. Sometimes the movement is so small that no person notices. Other times, entire cities feel it. Most people think earthquakes are only destructive events. To scientists, they are something else entirely. Messages. Every earthquake sends invisible vibrations racing through the planet in every direction. Those waves travel through mountains, oceans, deep rock, and regions no human has ever visited. They carry information. Not words, not pictures, but patterns. And those patterns reveal something remarkable. Because the waves do not move through every part of Earth in the same way. Some speed up, some slow down, some disappear entirely before reappearing thousands of kilometers away. At first glance, those strange paths make little sense. Why would a wave vanish beneath one part of the planet and return somewhere else? Why do different earthquakes produce different signals even when they seem equally powerful? The answers had been buried beneath our feet all along. Scientists eventually realized they weren't simply observing earthquakes. They were watching Earth quietly reveal its own internal structure. Every unexpected delay, every missing signal, every change in speed. Each one hinted at something invisible deep underground, something no drill had ever reached. Piece by piece, those clues began forming a picture of Earth's unseen interior, a place no one had ever visited, yet one that could still be mapped. In the next part, we'll follow those invisible waves into the planet itself, because the most convincing evidence for what lies thousands of kilometers below Earth didn't come from digging deeper. It came from learning how to listen. The idea sounds almost impossible. If no one has ever traveled into Earth's deep interior, how could anyone create a map of it? At first, scientists didn't have an answer. They only had observations. Earthquakes happened. The ground shook. Buildings collapsed. Then the vibrations faded away. For centuries, earthquakes were seen mostly as disasters. But hidden inside every earthquake was something far more valuable. Information. Imagine standing beside a quiet lake. You throw a stone into the water. Ripples spread outward. Now imagine the lake isn't made of water. Instead, it's made of different invisible materials. Some soft, some hard, some solid, some almost flowing. The ripples would behave differently every time they reached a new material. They might speed up. They might slow down. They might bend. Or they might stop altogether. Earth behaves in almost exactly the same way. Every earthquake sends enormous waves racing through the planet. Those waves don't choose where to travel. They move in every direction, straight through continents, beneath oceans, toward places no human has ever reached. By the time they arrive on the other side of the world, they carry with them a hidden record of everything they passed through. Scientists didn't need to see inside Earth. They only needed to understand what those waves were telling them. At first, the patterns looked confusing. Some waves always arrived sooner than expected. Others consistently arrived late. And some never appeared where mathematics predicted they should. That shouldn't have happened, unless something deep inside Earth was changing their path. Then came one of the most important discoveries in Earth science. Researchers noticed that certain earthquake waves simply disappeared beyond specific regions of the planet. Not because the earthquake had stopped, not because the instruments had failed. The waves themselves could no longer continue. It was as if they had encountered an invisible barrier. That strange behavior forced scientists to consider an entirely new possibility. Earth wasn't one solid piece of rock. Something inside had to be fundamentally different. Something capable of changing the behavior of the waves themselves. The planet was quietly revealing its internal architecture. Not through sight, but through physics. One unexpected pattern led to another. Scientists realized that different kinds of waves behave differently. Some traveled through both solid and liquid materials. Others could travel only through solids. When one group of waves vanished across enormous regions of the globe while another continued, the conclusion became difficult to ignore. Somewhere deep below the surface, part of Earth had to be liquid. Nobody had drilled there. Nobody had collected a sample. Yet the evidence kept pointing toward the same answer. The unseen interior beneath our feet was beginning to take shape, one missing signal at a time. Then came one of the most important discoveries in Earth science. Researchers noticed that certain earthquake waves simply disappeared beyond specific regions of the planet. Not because the earthquake had stopped, not because the instruments had failed. The waves themselves could no longer continue. It was as if they had encountered an invisible barrier. That strange behavior forced scientists to consider an entirely new possibility. Earth wasn't one solid piece of rock. Something inside had to be fundamentally different. Something capable of changing the behavior of the waves themselves. The planet was quietly revealing its internal architecture. Not through sight, but through physics. One unexpected pattern led to another. Scientists realized that different kinds of waves behave differently. Some traveled through both solid and liquid materials. Others could travel only through solids. When one group of waves vanished across enormous regions of the globe while another continued, the conclusion became difficult to ignore. Somewhere deep below the surface, part of Earth had to be liquid. Nobody had drilled there. Nobody had collected a sample. Yet the evidence kept pointing toward the same answer. The unseen interior beneath our feet was beginning to take shape, one missing signal at a time. But the surprises weren't over. As researchers placed more instruments across the world, the picture became increasingly detailed. Instead of one enormous underground layer, Earth appeared to contain several hidden boundaries. Some were surprisingly sharp. Others seemed gradual. Every time seismic waves crossed one of these invisible borders, they changed speed. Almost as if they had entered an entirely different world. One of the first major discoveries became known as the Mohorovičić discontinuity. Most people have never heard its name, yet it transformed our understanding of the planet. Before its discovery, the crust and the deeper interior were often imagined as one continuous structure. The earthquake data told a different story. Just beneath the crust, the waves suddenly accelerated. That change could only mean one thing. The rocks below were fundamentally different from those above. Without digging through them, scientists had discovered an invisible boundary beneath every continent and every ocean. It was the first proof that Earth's interior was organized into distinct layers. Not because anyone had seen them, but because the evidence had become impossible to ignore. That discovery changed the question completely. Scientists stopped asking, "How deep can we drill?" Instead, they began asking, "What else is Earth trying to tell us?" As more earthquakes were recorded, another mystery emerged. Far below the crust, far below the mantle, near the boundary surrounding Earth's core, the waves began behaving strangely again. Some slowed dramatically, others scattered in unexpected directions. Tiny regions seemed to absorb energy that nearby regions did not. Even today, some of those areas remain among the least understood places inside our planet. These mysterious regions are thousands of kilometers beneath our feet. No camera has ever seen them. No machine has ever entered them. Yet their presence is recorded every time the planet shakes. It's a remarkable idea. Some of the most mysterious places on Earth aren't hidden in remote jungles or beneath the oceans. They're directly beneath every one of us. By now, the story has completely changed. This is no longer about drilling deeper. It's about learning an entirely different way of seeing. Imagine trying to understand a person's heartbeat without opening their chest. Doctors don't immediately reach for surgery. They listen. They use signals traveling through the body. Earth scientists learn to do something remarkably similar. The planet constantly sends signals outward. Every earthquake becomes another scan. Every vibration adds another piece to the puzzle. No single earthquake reveals everything, but thousands of them, across decades, across continents, begin forming an incredibly detailed picture. That picture became so consistent that scientists developed comprehensive models describing how density, pressure, and wave speeds change from the surface all the way to the center. The remarkable part isn't that the model exists, it's that so little of it comes from direct observation. Almost the entire deep interior has been reconstructed from evidence rather than exploration. That realization leads to another question. If these models are built from indirect clues, how confident can we really be? The answer is more surprising than many people expect. Scientists don't rely on earthquake data alone. They compare it with laboratory experiments that recreate immense pressures. They study how minerals behave when compressed to conditions similar to Earth's deep interior. They calculate how gravity should behave if the planet has a particular internal structure. They measure subtle changes in Earth's magnetic field. Each method works independently, yet they repeatedly point toward the same hidden arrangement beneath the surface. Like witnesses describing the same unseen event from different directions, no single piece of evidence solves the mystery. Together, they become extraordinarily convincing. And yet, the deeper we go, the more certainty begins to soften. Because even with all these clues, the center of Earth still refuses to give up every secret. Scientists continue debating unexpected behaviors deep within the inner core. Some evidence suggests it may rotate slightly differently from the rest of the planet. Other studies hint that another hidden layer could exist inside the inner core itself. After generations of research, Earth is still surprising us. In the final part, we'll travel to the deepest known layers beneath our feet. We'll discover why Earth's hidden interior controls far more than geology. Because the unseen world below us doesn't just exist. It quietly shapes the world above us every single day. By now, Earth's interior no longer feels like an empty space beneath our feet. It feels like a hidden world, not because anyone has explored it, but because thousands of tiny clues have been assembled into one of the most remarkable scientific reconstructions ever created. And yet, the deeper we travel into that reconstruction, the stranger the story becomes. Far below the mantle lies a boundary unlike anything we experience on the surface. Above it, solid rock moves so slowly that it can take millions of years to complete a single cycle. Below it, an enormous ocean of liquid metal surrounds Earth's center. This is the outer core. No human has ever seen it. No drill will reach it anytime soon. Yet its existence explains something you rely on every single day: Earth's magnetic field. At first glance, a compass seems almost magical. No matter where you stand, its needle quietly points north. For centuries, people simply accepted that behavior. Today, we know the compass isn't responding to the surface of Earth. It's responding to something happening thousands of kilometers below it. Deep inside the planet, molten iron and nickel are constantly moving. Those slow, enormous currents generate an invisible magnetic field that stretches far beyond Earth's atmosphere. That invisible shield quietly protects our planet from charged particles streaming from the sunday. Without it, life on Earth would exist in a very different environment. The remarkable part isn't simply that the magnetic field exists. It's that one of the most important systems protecting life begins in a place no human has ever reached. The unseen interior beneath our feet isn't isolated from us. It's quietly shaping the world above. The deeper scientists looked, another realization slowly emerged. Earth isn't built like a stack of perfectly still layers. It's alive with movement. Not the sudden movement of earthquakes. Something much slower, much larger, much harder to imagine. The mantle appears solid. Stand on a mountain, and it certainly feels solid. But over millions of years, that same rock slowly flows, almost like an unimaginably thick liquid. That movement is known as mantle convection. Heat from deep inside the planet rises. Cooler material gradually sinks. The cycle repeats over and over again, not across days, not across centuries, but across spans of time so vast that entire continents are carried along with it. The ground beneath your feet isn't resting on a motionless foundation. It's riding on a planet that has been quietly reshaping itself for billions of years. That changes another assumption. Earth doesn't simply have an interior. Its interior is constantly reshaping its surface. Mountains rise, oceans open, volcanoes erupt, continents drift apart, all because of processes taking place far below anything we can directly observe. The unseen world beneath us is never truly disconnected from the visible one above. And still, even after decades of research, the mystery isn't over. The deepest part of Earth continues to surprise scientists. The inner core was once thought to be relatively simple, a solid sphere surrounded by liquid metal, case closed. But new observations complicated that picture. Some studies suggest the inner core rotates at a slightly different rate than the rest of the planet. Others indicate that its behavior may change over time. Even more surprising, recent evidence hints that the inner core itself could contain another hidden layer with a different internal structure. Think about what that means. Humanity has mapped the surfaces of distant planets. We've explored the moon. We've landed robots on Mars. Yet the very center of our own world still contains unanswered questions. Not because scientists lack curiosity, but because Earth continues to resist easy answers. Every new earthquake, every improved instrument, every refined model adds another piece to a puzzle that is still incomplete. Perhaps that is the most surprising lesson of all. Science is often imagined as a collection of final answers. But Earth's interior tells a different story. It shows how knowledge can become incredibly reliable without ever becoming completely finished. Scientists did not solve this mystery by reaching the destination. They solved it by following evidence. Each clue supported another. Each observation tested the previous one. When independent methods pointed toward the same conclusion again and again, confidence grew. Not because anyone had seen the answer, but because every alternative explained the evidence less successfully. That is why our picture of Earth's interior continues to evolve. Not because it is uncertain, but because good science never stops asking whether it can become more accurate. When this journey began, the question seemed simple. What exists 6,371 kilometers below Earth? Now, the answer feels very different. Yes, there is a solid inner core. Around it lies a vast liquid outer core. Above that, an enormous mantle slowly circulates over geological time. And above everything else, a remarkably thin crust supports every forest, every city, every ocean, and every human civilization that has ever existed. But those layers are only part of the story. The greater discovery is how we came to know they exist. Not through exploration, not through direct observation, but through patience, through careful measurement, through invisible waves traveling across an entire planet, through countless scientists willing to trust evidence over assumption. In many ways, Earth's interior remains one of the greatest places humanity has never visited. Yet it is also one of the best understood unseen places in science. That apparent contradiction is exactly what makes it extraordinary. The next time you stand on solid ground, it's worth remembering something. Everything familiar around you, the roads, the mountains, the buildings, the oceans, they all rest on an unseen world that has never been directly explored. A world that quietly shapes the planet we call home. And perhaps the most remarkable part is this. We didn't uncover that hidden world by digging deeper. We uncovered it by learning how to listen.